Bismillahirrahmanirrahim. So let us start with our session 8. So in this session, we have mainly 3 parts. That is the design of the beams as per ACI, and the design of the structure walls, and the design of the ramp and slabs, right? So let us go towards the design of the beam. So first of all, before designing any beam or in any software, or you do it in manually, first of all, you have to apply some checks, that is minimum longitudinal reinforcement. So ACI 318.14 limits for the minimum longitudinal reinforcement for the beams are defined in this section 9.6.1.2, and which it says on the right side, you can see that the AS minimum shall be greater of 1 and B, right? Except this section, this is another issue. You keep that as it is, and then go for the static determinate beams and flange and tension, all of these. So we have 2 limits, that is A and B, and A is 3 under root FC prime BWD divided by Fy, and the second is 200 divided by Fy BWD, right? So whichever is greater from these two, you have to select this, and that will be the minimum limit of their longitudinal reinforcement for the beams, right? So in our case, we have data BW, so our beam is 12 inches and our H is 24, right? So if I write H as well, we have H is equal to 24 inches. So if the D is calculated like this, H minus 2.25 inches, this is the cover from the outer fiber into the center of the bar. Normally it is taken as 2.25 inches. So if you subtract it from the 24, you will get 21.75 inches. So we have FC prime 3000 psi and Fy 60,000 psi. So if you insert these values in these formulas, 3 under root FC prime BWD Fy, please turn off your mic, please. Right. So I have calculated from the equation A, it is come out to be 0.71 inch square for our beam, and from the B, it is come out to be 0.87 inch square, which is the governing one. And how did we calculate that? Let us do that. So this is what I have done. So let us read this, and let us calculate. It is 3 into square root of 3000, and then into our B is 12, and our HD is 21.75, and then divided by 60,000. So we are getting 0.71, that is 0.71 inch square, right? This is the 1.7. So we calculated this. The second one is 200 divided by Fy BWD, right? So let us do that. So we have 200 into 12, that is BW, into D 21.75 divided by 60,000, that is Fy, right? So it's come out to be 0.87 inch square. So code says that you calculate these two, and whichever is greater, you have to select this. So in our case, this is the greater one. So we will select this as our minimum reinforcement. So if you are doing your analysis manually or by ETAB or SAP, so if the requirement of the reinforcement is come out to be less than this, so we have to provide this much reinforcement as a minimum reinforcement. For example, you have calculated your manual calculation, you get value of 0.6 inch square. So you have to provide the reinforcement as 0.787 inch square. It is the governing one as a minimum, right? So we have our minimum limit, that is 0.87. So let us go to the ETAB, right? So for the designing of the beam, normally beams are designed as in 2 parts. The first one is that you select all of the beams and do not consider torsion in the beams, right? So the first one is to design a beam for the flexure, is that you design it for the gravity plus earthquake with no torsion, right? So this is the first one. And the second one is that you design it for the gravity plus torsion with no earthquakes, right? So we will be doing this. So for the flexure design, you will select the gravity loads plus earthquake loads with no torsion. And for the torsion design, you have to select the gravity plus torsion with no earthquakes, right? So in order to not to consider torsion in your beams, there are two ways, right? The first one is that you have to go to the defined, then section, frame section, and then you go to the beam properties and click on the modifiers, property modifiers, and make it 0 or make it 0.001. If you write 0.001 or 0, because 0.001 is almost equal to 0. So in this way, the beam will be not designed or will not consider any torsion during the design of flexure for the gravity and plus earthquake. Because if you consider torsion and you have considered the earthquake forces, your all beams will be shown as red, and earthquake will fail all of your beams in torsion, which we do not, because if you do that, your structure will be more economical. Sorry, it will be a more uneconomical structure if you consider torsion with combination of earthquake. So this is the first way not to consider torsion in your beam. The second way is that you have to select, go to select, and then go to the object type and select the beams, right? So click on this, and all of the beams will be selected, right? And then go to the design, concrete frame design, and click on the second option, that is view, revise, overrides, and click on this 6 number that is consider torsion, which is asking your question. So you have to select yes and no. So if you do not want to consider any torsion in your beam, so you have to select this no and click on OK, right? And then you have to consider all of the combination in your design of your concrete frame, and you have to go to the load combination, select design combination, and then you have to consider all of the load combination, because you want to design for the gravity as well as for earthquake with no torsion. This is the first case. So we have selected all of the beam, and we do not consider any torsion, and we are designing it for the gravity plus earthquake. So I have already run this analysis in order to save time. This is the file which I have named at beams no torsion. So if I click on one beam, and if I go to design, concrete frame, and revise overrides, so you can see that torsion has not been considered in your design. But if I go to the design combination, all of the combination has been selected for the design of the gravity plus earthquake. Now I have run the analysis. It is same for that of the we have done for the column. We have to go to the design and then go to the concrete frame design and click on the start design, check it will design your system. And then after the analysis, you can click on this display design information and click on this design output longitudinal reinforcement. There are many different options, we will see about that. So click on the longitudinal reinforcement. So you can see that the longitudinal reinforcement has been shown as in 3 parts, right? So you can see that the bottom numbers are the bottom reinforcements, and the top one is the top reinforcement. And this 0.47 is the bottom reinforcement at the left side. This is at the mid. This is on the right side. Same for the top. This 0.84 is for the left side. This is for the mid, and this is for the right side, right? So normally you have seen in your structural drawings that few bars have been kept as a continuous, and then some has been contained, right, at different proportions. So you have to select it from here, that how many bars you need to go for the continuous. That, for example, you want to place 2 number 6 bars as a continuous bars, so you have to confirm it whether it will work or not. So you can see that it is 0.47 and it is 0.49. So you need 0.5. Let us make it 0.5 inch square. So you will need 0.5 inch square continuous bars in this beam, right? So what are the required bars more than the continuous? And you are selected from the mid, and then you have to provide extra bars at the mid using these values, right? So these are the different bars values, beams values you can see. that the on the top that is negative reinforcement and the bottom is the bottom reinforcement, right? So now from this you have to select the maximum, because you cannot name all of the beams differently. For example, if you because you can see that the reinforcement has been different for different beams. If you select this one, you want to name it differently, this is B1, this is, you can see there is a slight difference in the reinforcement. So this will be B1, B2, B3, and there will be hundreds and thousands of the beams in your drawing, which you do not, because you want to make your drawing simple and easy to be read by the site engineer or the other structural engineers if your design is going for the design review, right? So you have to select the maximum, which is normally equal for the all of the beams, and you have to give that reinforcement to all of the beams. So if there is any longer span in your design or your structure, so that you have to name that beams differently, right? So this is how you read this uh, design for the longitudinal. You can also display the shear reinforcement for the beam by going into that display information, and you can see the rebar in percentage, so you can click on the shear. So you can see the shear reinforcement in your beam, and you have to select the maximum from it, right? So let us go to the design detail of this beam, and then we have to select the maximum value from it, right? So let us go again into the display information and go for the longitudinal reinforcement. And we have selected this mid story because there is no connection between the one story to the upper story, but we have selected earthquake, so you can see that the reinforcement has been changed if you go up, because there the earthquake forces are being changed along the height of the building. So in this way you have to go through all the stories, and you have to select the maximum value in order to design all of the beams, right? So you can see that in the beams, the maximum value for the top is 1.2 in here, and there is no other value greater than 1.2 in square. And the software, you have selected the different load combination software, automatically give these value has been given automatically by ETAB from the governing load combination, and you can confirm it which load combination has been selected for the design of this beam, and we will see that in a while. So now you can see here is 1.6, here is 1.45, 1.3. So the maximum top is 1.6, and the maximum bottom we will see is 0.86. Let us go to another story. That is 0.7, 0.7, 0.6. This is 0.83. Let us go down. So now we can see the maximum value for the bottom is 0.85, and there is no other value greater than 0.85. We have to see in different planes and different stories in order to get the maximum, because there is no major difference in the reinforcement. But if there is a significant change in the reinforcement, for example, in your lower stories, there is no these two beams are absent, and these beams are resting on these beams, or the columns are not here, so there will be huge demand on some of the beams. So you have to name it or design that beam accordingly, right? So if all the beams are showing you very minor changes or differences in the reinforcement, so you have to select the maximum and apply it for the all of the beams in order to make that drawings very simple. Otherwise it will be hundreds and thousands of the beams. So the maximum value for the bottom is 0.86, and the maximum for the top is 1.61 inch square, right? So let us write in here. So from ETAB we are getting for the top it is 1.61 inch square, and for the bottom is 0.8. Let us make it 9 inch, right? So now you have to compare these two values with the minimum limit of the ACI. So we got the value for the top is 1.61 inch square, and for the bottom is 0.8, right? And the required value is 0.8. And you have seen that many of the beams have shown 0.86, and which is the minimum value governed by the ACI, right? So we are on the safe side. If this value comes out to be 0.5, so then you have to provide this 0.87 in your design, right? So now you have taken 0.9. So we are on the safe side. We have fulfilled this minimum longitudinal reinforcement criteria for the ACI, right? So let us go again, and let me click on one beam so I can show you different this design report. This is what ETAB is showing you, that the load combination 1.32D plus 1.1, that is earthquake. For this load combination, this beam has been designed because this is the governing load combination. So go to the summary. So now you can see that report has been generated, and there are different information that given in this report. That what is the section that you have selected, that is 12 plus 24, what is the load combination for which the ETAB has designed your structure. What is the length, what is type, it is sway special means SMRF. And these are the section properties B, H, and BF. Remember that ETAB do not take the effect of the effective flange of the effective depth of the width of the slab, that is BF. Normally it is greater than the BW, but ETAB keeps you on the safe side by taking BF equal to BW, right? So this is same, and this is the D, and this is the another properties, material properties, FC prime, and all of these, and these are the design parameters. So now our concern is this design moment for flexure reinforcement, and the top reinforcement is the design moment. This is the demand, right? And these are the rebar values, which is the minimum values, the required values, and this is the minimum reinforcement that is calculated by the ETAB automatically from the desired code that you have selected. So that is for the top, it is minimum 0.86, for the bottom it is 0.48, and the required one is this one because it is taken as a minimum value because your beam is working on a minimum reinforcement, right? And the last one is for the shear force reinforcement, that this is the demand VU, this is the capacity of the concrete, and it is the capacity of the steel that we'll be using, and this is the plastic capacity of the concrete, and this is the rebar required by the beam, which is 0.16 inch square per foot. We will talk about this shear in the design of the shear for the beam. So this is how you see the report for the beam, right? So let us go to and select number of bars. For example, for the top, let us select number 4, number 6 bar. So we have to divide this area of bars by the area of the area of the steel or the area of the bar. So we are using 0.44, which is the area of number 6 bar. So we are getting the value from it is 1.61 divided by 0.44. It's giving me value of 3.65, which will be equal to 4 number 6 bars, right? And for the bottom, it is giving me value which is 0.9 divided by 4, giving you 2.045. So we take as 3 number 6 bars. This is our final design for the flexure design of the beam, that we will provide 3 number 6 bar at the bottom and 4 number 6 bar at the top, right? So this was the whole story about the flexure. Now you want to see if there is any torsion in your beams. So you want to design it for the gravity plus torsion without the earthquakes, right? So how you do that, that you have to go to the, again, go to the select object type, beams, select all the beams, and then go to the design, concrete frame, overrides, and then click on this yes, and click on OK. So now the torsion ETAB will take the torsion effect on your beam. So if you have done it like this, you have to make it yes. If you have done it with the definition of the modifiers, so you have to make it 1 again. If you have done it from here, right? So you have to make it again 1. So now you have to go to the design and go to the concrete frame design and go to the select design combination. And now you have to remove all of the load combinations in which there is earthquake, right? So you have to remove all of these and keep only the gravity loads, which is the 1.4D, 1.2D plus 1.6 and 1.2 plus 0.5. And click on OK, and then you have to run the analysis. So I have done it all already to save the time, right? So this is the case in which I have selected the torsion effect in our beam. I can confirm it by clicking one beam and go to design, prime and override. So you can see that torsion has been considered in this case. And if I go to the load combination, you can see that only gravity load has been considered in the design combination, right? So analysis has been run. Let us go to the display, the concrete frame design, and display design information, and then click on the torsion reinforcement. I want to see if there are any torsion reinforcements I will provide in our beam, right? So you can see that normally you will facing these problems in your beams if you have secondary beams in your beam, in your system, right? So what I meant that is that, for example, if you have this beam, so let me do it. Let me do it in here, right? So if you have this one column, this is another column, right? And you have this, for example, this is frame, and this is the beam, and this is the beam, and you have secondary beams in here. For example, this beam is resting on this beam is resting on this beam, like this. So these secondary beams will cause torsion because we'll try to rotate your beam in this direction. In this beam will try to rotate your beam in this direction. So the torsion will be in this beam. So you have to check torsion in this beam and this beam, right? So if you have beam in this direction, so you have to check torsion in this beam as well, right? So these are normally checked for the gravity loads, not for the including the earthquake loads, right? So in our case, there is no secondary beams because you are the ETAB is showing me 0 torsion reinforcement. But if you remember, we have one system like the primary secondary beams in here. It will show you some torsion reinforcement, and these are this one, right? Because this beam is connected to the slab, and this beam is trying to rotate this beam. So there is a torsion in this beam, right? So there is no other torsion. So you have to right click on this and go to the summary, and let us go to the torsion part. So it is showing you that there is a torsion reinforcement required, which is equal to 1.3425 inch square. These are the longitudinal bars and these are the shear bar. The shear reinforcement is normally incorporated in the design of the shear force. So you do not have to worry about this shear, but this is important that these are the longitudinal bars required by the ETAB, right? And you have to provide these bar in this only in this beam, right? So we will detail this beam separately. All of the beams will be named as B1. Only this beam will be beam as B2 because we will provide extra 2 bars at the mid depth of this beam. Like for example, the shear reinforcement is like this. For example, this is the beam. So these are the flexure reinforcements, right? So what we have seen is that these values, the torsion reinforcement you have to provide here at the mid depth of the, so these are the torsion reinforcement for the beam, right? So whatever value you are getting from ETAB as AL means longitudinal reinforcement for the torsion, you have to provide it in the mid depth of this beam, right? So this is 1.3 inch square. So let us write here torsion is equal to 1.3 inch square, which is come out to be 1.3 divided by 0.44. So it is equal to 1.3 divided by 0.44. It is come out to be 2.9. Right? So you cannot provide unsymmetrical bars. If you are willing to do it, so you have to provide 4 number 6 bars, right? So each 2 bars will be on the other side of this beam. You can change the dia of the bar if you want to use only 2 bars. So you can use 2 number 8 bars, which is come out to be 1.3 divided by 0.8, which will come out to be 2 bars, right? Or you can use 2 number 8 bars, right? Or whichever is feasible. If there is no bar available of number 8 in your region or in the construction side, so you have to go for number 8. If there is no availability issues, you go for the number 8 bars, right? So this was the whole story about the flexure design of the beam. Now let us go towards the shear design. And before going to the shear design, there is another limit on the longitudinal reinforcement, that is the maximum ratio. ACI 31814 limits for the maximum longitudinal reinforcement for the beam can be calculated using the ductility requirement. As for the concrete strength is 0.003 and steel strength is 0.005. Right? I assume that you all of you know what is this mean, because we are not going into detail for it, because you have studied your master courses, your PhD or undergraduate courses, that the maximum value is 0.271 into PWD FC prime divided by FY, right? So if you do that, for in our case is BW is 12, D is 21.75, FC prime is 3000, 6000, it comes out to be 3.5 inch square. That you cannot provide reinforcement greater than this number, right? So in our case, if you insert our ETAB values, right, it is within the limit. So we are within the limit because in the top we have 1.6 and at the bottom we have 0.9 and the limit is 3.5 inch square. So we are on the safe side, right? This means if you provide reinforcement greater than this value, so your structure will be not ductile, it will be greater failure in your structure during the design earthquake, right? So this was the whole story about the longitudinal reinforcement in your beam, how you design it for the gravity plus earthquake with no torsion, and then for the torsion we have to consider gravity plus torsion. Now the next one is the design for the shear reinforcement for the beams, and for the shear reinforcement you have to consider the earthquake plus gravity loads, right? So there is a limit in the minimum reinforcement of the shear, and you can see that in table 9.6.33 that for the non-pre-stressed beams you have to select greater of 0.75 under root FC prime PW divided by FY and 50 into PW divided by FY. So you have to provide at least greater of this as a minimum shear reinforcement for your beam. So in our case, it is 0.75 And all of these value we have BW 12 and FY 60,000. It comes out to be 0.083 inch square per inch. And for the second equation, we have this 50 PW divided FY, and for our case, it comes out to be 0.01 inch square per inch. So this is greater than this. So this is the governing. So for your manual calculation, if you have done manual calculations or from ETABS, it's the software is showing 0 share. So you have to provide at least this much shear reinforcement for your beam, right? So let us go to ETAB, and then we will see how much reinforcement is given by the ETAB for our beams, right? So we'll do it in this next part because there's only 3 minutes remaining. So I will stop the recording and I will share the new link in WhatsApp, and so we can start our second part of this session.